Hey everybody, this is Larry. This is day 12 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Hopefully it's slightly easier than yesterday's. I think a lot of people struggle with yesterday's. Well, at least the linear solution. The n squared one I think is much more doable, though still not, easy per se. But yeah, I hope everyone's having doing okay. It's almost Friday here in New York City. And I am just beat. I just did 13 miles in this brutal temperature, and I'm just like tired. I had to like lie down for like an hour before even attempting this video. So hopefully, I have enough energy to finish this, have some dinner, and then keep going. Today we have 1717 maximum score from removing substrings. So okay, so you given x and y, you could remove a, b, and gain x, or you can remove b, a, and gain y. This is a very tricky one. There's also non-a, b operations. Wait, what does that mean? You just cannot remove them, right? Okay. This feels like one of those tricky ones because I think the hardest problems for me are problems where you have to make a decision, and what I mean is choosing one or two of the both, and yeah. And a lot of times, very often, is dynamic programming or some sort of greedy or some sort of thing that allows you to figure out how to proceed from the decision, right? N is 10 to the 5th, which means you can't do anything n squared like we did yesterday, but you have to be a little bit smarter. I think the one thing that I would think about is that if we have something like a, b, a, b, a, b, a, this is probably the worst case for it in terms of decision, but maybe not actually, right? It may seem that way, but in a way, there's only two possible ways to solve this, right? It's just A, B, and then you greedy it all the way through. So there's only two ways, and it's a greedy in that way, whichever gives you more point, X or A, B, or B, A, right? So then now, how do we figure out the rest? Is it a stack problem? And I think the idea behind solving it using a stack situation will require some sort of finding out and proving invariance, right? And for example, for this, like maybe you could say there's a decision between A, B, A, right? But as a result of this B, it's not a real decision because then now you have A, B, A, B. But that might still not be, or in the sense that this is not a real decision, is that you can locally change it, right? Because let's say you have A, B, A, B, even then, even if BA dominates, like BA is equal to 1,000,000, say, that's only 10,000, but okay, AB is equal to 1, you could still take out the BA and then have AB in between, right? So that means that you will never do AB, AB no matter what. So there is some like weird invariance here. And I have some like gut feeling about it, but to be honest, it just feels very awkward. Like, as a result, I have a feeling as a result of both this requiring a linear solution and this thing that it is going to be it's going to be some sort of greedy. But it's just so hard to prove. I think that's my point, right? And there's also a lot of nuances around greedy as well. Though in this particular problem, it should be straightforward to suss out the subproblems, right? And the subproblems is just that we divide this long string into components that are divided by non-ABs, right? For example, this C, that means that we could ignore everything before the C, even though there's nothing before the C anyway, but we can ignore everything and just solve for for this thing, right? And how would we solve for this thing anyway? Like, because in phi you do, right? But you can also do this BA first, AB. I mean, I guess like here you're forced to, but I think the ABAs are kind of tricky to figure out how to handle, right? Or conversely BABs, of course. But I'm also just trying to think like, what is the strategy behind this, right? Like, is there an exchange argument type thing, right? Because okay, so there are really only a couple, and maybe it's the exchange argument and the greedy and all these things are kind of hard to prove. The way that I would maybe think about it is just doing it like a case analysis, right? So let's say we have ABBA, then it really doesn't matter because there's only one way to do it, right? And let's say there's ABA. Well, here then you do have to make a choice, and it's greedy, and it makes sense because you have one left over. If you have ABAA, then it's the same thing as this, so it doesn't change anything, right? But if this is a B, then it also doesn't. The greedy is very easy because it matches all four characters no matter what. So you, in a way, it's locally optimized, if that makes sense, right? So then the only thing that you have to actually like have a leftover is if you have like this thing, right? And if you have AAABBB, then you have no choice anyway. You only have one thing. But what do you have something like this. So then now you reduce this to like here, or maybe even here, right? And then now, like, what is the greedy part here, right? This is a very hard problem, if you ask me. It's either that or I'm just missing something really obvious, which also could be true. Because even if you have, let's say this one, right? Let's say you put a stack-based solution and you just like you see A, you see A. But what if you have B, A, B, right? And AB is worth a lot. Then of course you want to do the AB first. And is that how you do the greedy? Just do it that operation first no matter what? Maybe? Can you generate? And then now I'm just trying to think through that algorithm. Let's say, I don't even know if this is true, so it's kind of really a tough problem. But let's say we have a greedy thing of just removing all ABs and then remove BAs as we get later. Is it possible? I'm just thinking, is there possible to that there's a sequence of move that requires you to remove ABs, then BAs, then ABs again? Or is it like you could do all the ABs first and then BAs and then you're done, right? And I'm trying to think through that scenario, right? So here, let's say you have AB, and then maybe you have to do a BA. So maybe something like this. But is there like an AB here? Like something like that? Because then now you remove AB. Now, but then here, then now you just remove AB, AB, and then AB, right? So, okay. I don't know. To be honest, I have no idea how to prove this. Right now, I just have some gut feeling about, just some gut feelings about this, really. In sorts, and that's the thing with these things is that, yeah, I mean, I have a gut feeling it's a little bit of a greedy. It's not a strict proof. I mean, I think I kind of did a pseudo proof by enumeration and maybe like, but it's not really a proof. It's just that I cannot find a counter example where you would just do AB first and then BA second or something like this, right? So maybe we can just play around with that. And you could even do greedy and figure out XY, but I'm just going to be a little bit lazy. And then, yeah, let's say we have South S, right? And here we optimize for AB and then BA, right? Say, so now we have or let's go A, B, and BA, because that's just more reasonable to remember, right? So then now the first thing we do is that maybe we split everything by non I guess we don't even have to. I mean, I was going to say we could probably split everything by non-ABs, but you know, we have for C and stack, right? So, oh, not on stack, on S. So then we append C, right? If length of stack is at least 2, and so yes, the last character is B, and the second to last character is A, so this is AB, right? Yeah, then now we can remove, and then we do points or something, right? Points. Points at AB, and then stack.pop, stack.pop, right? Okay, and then now yeah. Yeah, and maybe I could even do this by just having a thingy, a helper, right? Let's say P self for partial self, S, and then points for AB, right? Just maybe X, and then I don't know, A and B, right? Something like that, if that makes sense. So then I can just do this. So this is B, this is A, and then yeah, and then we can return return stack points, maybe. So then now we can partially solve the current S. X is going to be AB, and then we just A and B, right? So then now this gives us the stack and points to go to this, right? And then now we can solve again with the stack, BA, B, and A. P2 for points 2, and then just return this plus P2, right? Maybe something like that, right? And then now we can solve S, X, Y. So then now we can return max of this and solve of maybe just inverse S, Y, X, right? And the inverse is just us inverting the A and B, right? So maybe we can do something like, array is equal to right? And then for X and S, if X is equal to A, array that append B, else if X is equal to B, append A, and oops, and then else return append X, and then I'm just being a little bit lazy on the typing too. So then someone like this. Right? Oh, whoops. Okay. Why do I have a 20? That's a little bit awkward. Yeah, that's the thing with not testing stuff. So okay, 8 and 8, so that's 16. This should return. This should print 2 things, right? Why is this only returning one or printing one thing? Oh, because the inverse, this is an array. Okay, I mean, we could join it. It doesn't really matter, but that's just for display. Okay, the reversing seems to be okay. But now we have 15 and 5, which doesn't make sense because, well, 8 and 8 doesn't make sense anyway, because you're not supposed to be able to. Did I mess this up? No, X, Y. No. And how do you get? Oh, because this is A, B, and I meant X. Okay. Okay. So all that, and because I had a typo. Okay, fine. Because it didn't really make sense. But okay, let's give it a submit. And I got a wrong answer before, which I'm not surprised because this one seems hard. And basically we just kind of did all brute force on some sort of greedy. And I don't think you even need to, honestly, because I think you can probably just do an if statement on X, Y, but I don't know, I just didn't want to think about it. But it still requires like a little bit of greedy guess. I mean, I think you could do an exchange argument on something like this based on the cases that we kind of, I went over it a little bit, but not in too much detail, admittedly, because I don't know. It's a hard problem, I think, if you want a strict proof. Let's take a look at the solution. Greedy. I mean, yeah. I mean, that's how we solved it, but this is not like, there's no proof. I think that's the. These are just like algos, but they don't provide proof to this, which is like not very. Not very useful. Like for me, that's and I think the thing is that this problem only works when you have two things like A, B, and BA, because of like, and I think that is the part that is a tricky ask, if you ask me, in that it doesn't generalize to, I think, even three things, just because that's it just creates a lot more permutations and the decisions are way more numerous. So I don't think you could do it on greedy as a result of that. So this only makes sense for this particular problem, and without proof, it's so particular that I don't know what you can learn from it. I think that's my general yeah, I think that's my general thing for this problem. That's my general feedback. I don't know what to say about this. I mean, like there's, I mean, using stack obviously is important to figure out how to remove it, but I think stack is not the hard part about this. Stack is like just a thing, right? It's a good hint. Yeah, but why? I don't know. Yeah, I mean that's fine, but I don't know. I like I get it, but I don't have a good way of explaining the greedy because this is a hard problem. And a lot of my gut is just because I've solved a lot of similar problems, so like I'm leaning that way, but I don't, like I don't think that's a good way to teach, obviously, so I don't have a good thing for you. I think if you really want to go for a strict proof, you should do what I did earlier with kind of case analysis, right? Because there are really only a couple of cases that you can really build out. Like I said, like maybe ABA, maybe this, right? And everything else is just variation of this, or like the flip version with B's or A's and stuff like this. And those are the only hard tricky ones. The odd number ones, we always said that it makes sense, and the even number ones, I guess there's already a solution, right? And then everything else kind of builds from that because, because then now if you want to add A, B, or BA in any like either in the before, then it just decomposes, so you could kind of figure it that way. And it doesn't even have to decompose in the subtract the 2 bit from the beginning. You could also subtract from the BA in the middle, right, to get to here. So in that way, it's kind of, and if you have something like this, then there's no decision, right? Because this is just AP and you can't do anything with it. I mean, maybe there's some ways you can do the different order or something like this, but I don't know. So you can maybe do a proof by a kind of like exhaustive case analysis, but that's like very unsatisfactory. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Have a great weekend, everybody. Bye bye.